We're really pleased to launch our year-long series of discussions on AI and humanities today. And I'm very happy to be organizing these discussions with Amarda, Shehu. As always, we at CHR would like to thank Andre Marshall of Research, Innovation, and Economic Impact, and Ann Artis, Dean of the College of Humanities and Social Sciences, for the funding that makes our work possible. A great thank you also to Catherine O'Lean, the Associate Director of the CHR, for her work for organizing the whole series, which has involved a heavy lift. The series brings together George Mason faculty from the Humanities and from the College of Engineering and Computing to discuss with each other and with all of you a range of issues central to engaging critically and constructively with the increasing presence of AI in our world. The terrain is huge and continually evolving, and we will only be able to thematize a selection of issues in the topical sessions, but we have also scheduled 2 open topic reflection sessions, one at the end of each semester, where other issues can arise for discussion and where our community can discuss collaborations, projects, and lines of inquiry that we'd like to see pursued. The series will continue later this month on Thursday, October 30th from 11 to 12:30 in the same room with a discussion on language, meaning, and LLMs, large language models. And then we'll continue monthly through the fall and spring semesters, and we hope you'll be able to join us for all or most of the discussions. Those sessions will take up many of the broader conceptual, social, and political issues around AI. Today, however, Amarda and I would like to open up the discussion by addressing some fundamental concepts and questions around AI, to take a peek under the hood of the technology itself, as it were, to help all of us gain a better footing for the discussions that will follow. As a professor of English literature, I come to the topic of AI with very limited background knowledge and a lot of questions. So I hope I can serve as a useful proxy for the person on the street to initiate discussion by asking questions that some of you might also share, though others of you will be able to pick up and continue the discussion at a more developed level. But the aim of this series is to engage as wide a range of faculty and students as possible in thinking about these issues and to help us all move to richer understandings of the terrain through interdisciplinary discussions, that we will be holding. And I hope the questions I'll be asking today, basic as they are and focused narrowly on how AI systems work, will nonetheless help to open up lines of inquiry about AI and its operations and potential impacts. The subsequent discussions in the series will be much more balanced between humanities and computing folks, each engaging with the focal topic from their perspective and discussing it with each other. But today it seemed to us most productive to have me ask questions of Amarda, so it's a little bit.
I'm in the hot seat.
Yeah. This makes it easier for me, certainly, but you all can continue the discussion beyond where we leave it. Let me just add one comment about the series before beginning the discussion. In many contexts, there is a feverish rush around AI at present, a fear of being left behind and missing out, a rush to jump in while the boom is on, and very likely the fever will break at some point and then we'll be in the post-boom phase of AI. This series isn't meant to contribute to the feverish dynamic, but to enable engagement with AI for the longer term. So even though our discussions are taking place during the feverish rush, the aim is to step back and examine different aspects and entanglements of AI in our world, to open things up to different views and perspectives, and to delve deeper into particular aspects of AI so as to foster engagements with AI that are both productive and critical. So with that, let me turn to the questions that I've prepared. Amarda. So let's begin, Amarda, by trying to unpack a little bit what is meant by AI or artificial intelligence. There are broad philosophical and conceptual issues loaded in the use of the term intelligence in this label, and what might be meant by it in this context. But I'd like to approach the terrain by a more nuts and bolts avenue and ask what's distinctive about AI systems compared to regular computing, not so much in terms of what they can do, which we might have some sense of, but in terms of how they are designed and how they operate, potentially both in terms of hardware and software. And where does the much more modest term machine learning fit in relation to this distinction between regular computing and artificial intelligence?
Right. So first, I will not be as eloquent as Alok. I have to say that up front. But I will do my best. It's very hard to unpack all these questions in a limited amount of time. I don't think I can introduce all of AI even in one semester, which is something that I'm trying to do this semester. And I have 2 students for my class right here in the audience. So thank you for representing. It's funny, my class is a bimodal distribution. There are the 18 to 21-year-olds, and then there are 50-plus-year-olds from the community, because we all want to understand what is this new thing that everybody's talking about. I will probably really grossly, overly simplify what AI is, but it comes with the territory. I have to limit myself. But I think I will juxtapose to answer the first question of how is AI different from computer science. I'm going to grossly oversimplify computer science with the task of writing a linear set of instructions to perform something, right? Not in natural language, but in some structured language, in a programming language, of which you may have heard of. There are different versions. There were different versions over the years. Yadav, Alok, I keep saying Yadav because in my brain, they both seem like first names. So Alok mentioned the boom and the post-boom, and there was a very interesting boom and a post-boom that happened with, I would say, a version of AI, which was closer to classic computer science than where we are right now. And that was expert systems. Anybody remembers from the 80s? Okay, I was born in the 80s, so I did not experience that boom and post-boom. But that was, I would say, the first time where we were trying to encode our understanding about processes or about the world with very long, or you can think of it as very long rules. If then you find this fact in the database, then the answer should be this. And so there would be these really well laid out instructions but using symbols rather than natural language. So that was the stage of what we called symbolic AI. And a lot of businesses started getting created, a lot of promises were made. The federal funding agencies, sort of the arms of the government, got very excited. DARPA started, putting a lot of money in it. And then we hit a bottleneck for various reasons. There wasn't enough space to write off those instructions, and there were always exceptions to the instructions. So these systems were very brittle. And it's interesting that they mirror what we're experiencing now with AI. So now how is, I would say, current AI and machine learning, you mentioned, different from that, which is very linear set of instructions. We bring our understanding, we structure the knowledge that we have, and we try to deduce something. Now we have moved from deduction to inference. And the shift has been quite transformational. We don't have to think about the rules. We don't have to think about the instructions. We moved from writing down rules to showing examples, showing data. And we changed conceptually how we try to model the world or how we try to model our understanding of something by mathematically thinking that observations we see in the world are outputs or products of some function that we don't know, possibly an overly complex function that we don't know. And what we will do is we will create some architecture, we will put some constraints to guide our machine or our computer towards a family of functions. So we may say things such as only consider linear functions, right? They look like a line. Or only consider quadratic functions, or consider higher dimensional functions. So we don't necessarily put rules, but we put constraints, mathematical constraints that guide the machine towards a family of functions. We might tell it, here are the number of variables, but I don't know how they mix together in this soup. It's your task to figure it out. And how does the machine figure it out? We tell it that for these observations, these are the things that we want to be able to predict. So for instance, we may want to predict who's in this image. If we're tracking faces, we're tracking people. We may want to predict what is the sentiment or the emotion in these texts. So the text the images, Fitbit data, those are our observations, our examples, our data instances, and we want to predict something about them. So we come to the machine and we say, for these data, this is what we know. Now, we want you to navigate this family of functions, figure out how the variables should combine. If there are like constants, in front of them, what should be their values, you need to figure it out. But in your search, you will be rewarded or penalized by how closely you match the predictions that we already know, right? And so every single modern AI system, that's what it does. It looks at the data, it has some guidance on what we expect it to do, it navigates a family of functions, and it figures out what that should be, what the answer should be, what the function that generated the input data is, based on an objective. It tries to really optimize an objective. The objective is basically to match, if I simplify, to match the predictions. And we may say, you need to match it very closely, or we say, around. So we can create other functions that say, this is the objective function that you should optimize. And so this conceptual shift also has made every modern AI system probabilistic. Rule-based systems are very deterministic, right? A implies B, B implies C, C implies D, you just deduced D, this understanding about the world. Now these systems are probabilistic. First of all, because they have to navigate a large family of functions. They only see a very limited understanding of the world, the one contained in the input data. And then they're just trying to match our objective function. They're trying to really please us, right? So very often they will land in a function that may not be the one, but it's close enough in the sense that it matches the objective. It does what we asked it to do, but it does not have any inherent understanding. It doesn't have any inherent intent. And so very often you will hear faculty, we also have a famous faculty in CEC, and she says modern AI is linear algebra on steroids. I don't particularly, that's not my style. I don't particularly like the term. But what I appreciate in that is that it clarifies the clutter and it says it's really math. It's really math. It's really linear algebra because underneath, we package things as matrices. It's a lot of it's a mathematical system. Now, the other point that I wrote here, you asked about so there are kind of two phases that I am teaching my students. There is the sort of the offline phase, the phase where we say, here, we want you to train over the input data to match these observations. And this is how much we're going to penalize you and hold you honest to, did you match the observation? We call this the training phase. And once the model has finished and said, I'm done, then I'm simplifying it, we take that model and we deploy it, we put it in the real world. And that means now we give it new data for which we don't know what the sentiment should be or who's in that image. And we ask the model to go and infer from the test data what should be the observation. So these are the two different, really overly simplified training that happens kind of offline. You don't see it, doesn't affect you. It's the engineer, the team, and then the inference when the model is being deployed, it's being used and it's making observations about the real world. And this is where we often see very interesting failure modes. We see, for instance, systems that are unable to generalize. They did so well in the lab, in the training data, but then in the test data, when we monitor them, they fail spectacularly. We call this by different names because the reasons may be different, but very often the case is the real sort of diagnostic here is because the test data, the real world, somehow doesn't look like the training data. Or the model, the data look the same, but the model hacked the reward. It figured out a way, it's like the kid, you're giving brownies for the kids to actually do the studying, but the smart kid found another way to get to the brownies and actually didn't do the study. And there are a lot of examples, some spectacular failure modes that have been out there in the PR. Finally, one final point, the hardware is super important, especially in the training. These systems can be really not just data hungry these days, meaning they need a lot of instances in order to learn the right thing, but they also need a lot of computational power. The functions that we're talking about nowadays, they have trillion parameters, trillion variables, right? It's not like the ax plus by equals c. It's like x to x 1 trillion parameters. And so to figure out what the right connections, relationships should be between those variables, these systems need to spend a lot of time. While it's hard to obtain some, because the companies don't necessarily tell you upfront, the current modern systems in pre-training, like GPT-4, took about 3 months, 90 to 100 days of training over 25,000 NVIDIA really high quality A100 GPUs, very specialized hardware architectures. But the software stack in all modern AIs looks about the same. You train it, you should do some evaluation, and then you deploy it or test the data in the wild.
Right.
And I think I'm going to stop there.
Yeah, no, thank you.
Because we can go on forever.
Yes, each of these questions, is a semester's worth of unpacking involved in the chat. We'll just do brief introductions here. So these days, when we think of AI, most of us think first and foremost of LLMs, large language models like OpenAI's ChatGPT or Google's Gemini or Anthropic's Claude. But the term AI is an umbrella term for a wide range of AI systems and tools. And recently, we've been hearing a lot about agentic AI. Could you give us a sense of the different kinds of AI systems and tools and how they differ from one another?
Right. How many weeks of teaching are we now? 10 weeks? 7? Feels like 10 to me. And I've covered very little just answering that question, as my students can attest. Okay, so let me unpack that very quickly. Not all AI is machine learning. I used to do something called optimization, didn't care about machine learning. And not all machine learning is LLMs. And actually, LLMs are an umbrella underneath something known as deep learning, where these functions are really big, but they're constrained over specific architectures. That's how we constrain the family of functions. In terms of trying to make sense of machine learning and deep learning, one way that I tried to help my students that came with, I assume, zero understanding, was to talk about learning paradigms or learning families. So let's talk about a taxonomy or a hierarchy, right? So when you hear these days AI, many people are like ChatGPT. No, let me even constrain to machine learning. Think of machine learning here at the top, and then you have these two branches, and I'm going to say here is predictive AI and here is generative AI. And again, I cringe a little bit because it's like, no, it's predictive machine learning. We're going to say AI, okay? So we have predictive versus generative. This captures the fact that what we try to do, and engineers like to talk about tasks. What we're trying to do is we're training systems to perform on prediction task or predictive task versus generative tasks. And the LLMs, the ChatGPTs, the Claude from Anthropic and all whatever, Groks of this world, the llamas and everything, they're here in the generative. The DALIs, they're here in the generative. At least primarily the way you're using them for generative tasks because they're generating new content. It can be on one modality, so maybe only text, maybe only images, maybe only video, or it can be multiple modalities like Sora 2 that came out. I'm still waiting for my access code. I'm not important enough. Where you can get both modalities, video and audio at the same time, right? Even in ChatGPT, it's not one modality because it can create images, captions for that image, right? And we take that for granted. But this generation is generating content. And so really modern AI does a lot of generation. Before that, and somewhat, I would say even more importantly, but doesn't get enough PR these days, is predictive tasks. Predictive tasks are those where we're saying things such as predict the price of this house, right? Predict whether this person should get a loan or not, right? predict whether this person should get bail or not, right? And I'm not like taking this out of the hat. These are real predictive AI systems that are being employed in banks, are being deployed in police stations, New Jersey, like not all because the rules are kind of fuzzy. Predict the emotion. And this is huge in marketing, right? They engage with you, they want to predict what was the emotion that it invokes because they're it's a money-making venture. So typically under prediction, we have different ways, different things, or different learning families. So very often the simplest one is the supervised learning. The supervised learning is the one that I explained at the beginning, where for observations that we're showing to the AI system, we also tell it that, well, this text invokes anger. The speaker is angry. This one, they're happy, so we're labeling. Or the price of this house is this much, this other one is this much. And so then the system, we're kind of holding it by the hand. We're saying, I'm supervising you. I'm showing you the answer in training. Then when I take you out in the real world, I'm not going to supervise you anymore. And let's see what you do, right? And this goes also by different names, classification, if we're predicting labels, good, bad, dog, cat, human, not human. Or regression if we're predicting numbers, price of the house, stock market the next day, like actual numbers. Under this umbrella, you may have also heard the big deal these days, which is really not new, reinforcement learning. In reinforcement learning, we're training the machine to, it looks like a generative task, and we're trying the machine to figure out what is the next action when we put it into real world. What is the next thing you want to do? This is very important, for instance, in robotics, where we want robots to learn how to move out there in the environment, but they pull micro actions from a library that we have put together. They just figure out the right combination of those that will get them to do the right thing, not trip. And how do they do it? Again, we give them the objective function. We say, I'm going to give you brownie points for doing it right, or, oh, I'm penalizing you. You did so badly. In generative AI, we have different learning mechanisms and even things that we didn't think that these systems were able to do. I'm going to pick one of them, in context learning. And in context learning is, we didn't think that, when we interact with a system, that it does anything beyond generative, but you can then ask about it. What does this mean? Is the speaker angry? Is the speaker happy? Like you actually can get these systems to answer things to you for which you didn't train them explicitly. So there are a lot of learning paradigms. Under the, I'm trying to remember now, agentic AI, right? I don't like that word at all. And there's a lot that you can unpack there. We spend a lot of time in my class to saying, what kind of AI agent is ChatGPT? Because the way that we at least tried to understand or define, set the rules for what an AI agent should be, agent implies agency, yeah? None of these systems actually have agency in the true meaning of the word, and I'm sure folks here can tell me what agency is. I don't even know what intelligence is. You pick a computer scientist, what's intelligent? I don't know. What is reasoning? I don't know. Then maybe you shouldn't talk about it, right? Okay. But agency implies that you can set the goal for yourself, right? I set a goal. Like, my goal right now is not to be a fool in this meeting, okay? These systems don't set the goal for themselves. If you have interacted with ChatGPT, you ask it a question, you give it a goal, and then it comes back and says, how do you want it? Do you want any more? Right? So it's like holding a child by the door. So by the hand. So they are not truly AI agents, at least in the way that smarter people defined it, but we're going with it these days. And I use we here very loosely. There are a lot of incentives, financial incentives, for trying to make this system look like they reached being AI agents. Now, agentic AI, you always have to ask the business folks, what do you actually mean? Because usually those are the ones that brand things before computer scientists. I know we get a bad rep, but no. You ask business people. So agentic AI is this this aspiration, I should say, to orchestrate a system where you have multiple AI agents performing subtasks. So you say, I want to go to this concert by, what's the one my kids like? I'm blanking out. Tells you how much I don't care about that singer. Huh?
Hey, let's wait.
Thank you. Yes, that one. So say, I want to go to this concert. Right? So you give this to a system that has many AI agents sitting there. What kind of AI agents? Well, because they're not truly AI agents, they each are specialized to perform a specific task. So there may be one that goes out there, figures out based on, internet, oh, there is a concert here. Where do you live? I live here. Okay, this is a concert. Would you like it? Yes. And then it hands off the task to another agent that does booking. And then another one that is supposed to tell your friends that you just booked this, right? So it's really like a team. So agentic AI, we're trying to get into this stage of having a team of AI agents that you give them a goal, they can break it down into subtasks, and each of them can do a subtask, and they communicate with one another, and voila, everything works. And I say voila because there's a lot here that can go wrong. One of the things we're noticing is, forget about the fact that each of these agents is brittle by themselves, is compounding errors, a game of telephone. Like I tell you this and you tell me that, and then when at the end it's like, what did you do? What did just happen? So OpenAI had a huge dev development day yesterday. I didn't have time to see the opening thing by the person I absolutely love and adore, not Sam Altman. They're moving into sort of here, you can build a team of AI agents. This is the next phase of AI, agentic AI. The aspirations don't quite meet the capabilities. I myself have tried. I have a lot of trouble. I've showed to the students in class, even for simple things. The agent just disappears. Like, I don't know what's happening. It doesn't come back. There's gaslighting that happens. There's like things that my kids say, oh, that you're being trolled. I'm like, that's what that is? So they're not there, but that is the next thing that they're saying where AI is going, the agentic AI stage. I will close with this statement. The CEO of Signal, somebody I really admire, broke it down. She had a mic drop moment. Somebody asked her about agentic AI. And the example I used, the booking and sharing with your friends, was important because she said, let's figure out how this would work. Just like walk with me through it, because when you get into the details, then you start to see that things break. And how can the agent email or contact your friends? Your friends are on WhatsApp. Isn't that private, secure? You can't allow the agent to get into your WhatsApp or on your Signal, right? So she was saying, ooh, there are huge privacy and security issues. Forget even if you figure out the wrinkles technologically of how these agents can interact with one another. So there are actually a lot of headwinds, but from a business proposition point of view, that's the next thing.
Well, great, thank you. So this next question circles back to a topic that you've already opened a little bit, but maybe I can ask you to pursue it a little bit more. So there's been a lot of controversies around the sourcing and collection of training data for AI models, and we'll get into those issues in other sessions. But here I'd like to ask you, what is involved in the training and testing and optimizing of AI systems? We hear about pre-training and reinforcement learning, as you mentioned, and alignment, and the setting of different parameters, such as the temperature of an LLM model. What are these terms referring to? Is training a finite process or an ongoing continuous process? When new LLM models are developed or other AI systems are developed, are they improvements on the existing model, either through richer training data or additional training, or does the new model have to be built from the ground up?
Okay, that's a lot. So let me try to answer your questions with anecdotally with the experience, so that then hopefully I can break it down into what's happening. Maybe not many of us, but some of us do use these systems. So let's suppose that you are one of them, and no hands raised. And you use, I'm just gonna go to ChatGPT, okay? It has the most name recognition. When you interact with ChatGPT, you are not interacting with a large language model that the company produced. So what model are you interacting with? So let me give you back. The large language model is large because it has like trillion parameters. We actually don't know what the threshold should be to call something large, but we kind of recognize that when we got into the billions, we're in a large territory. So you could call them super large now. And it's a model because everything that comes out of modern AI, we're calling it a model, right? The model contains the function that it has learned. It has the parameter variable / weights. We use these words interchangeably. And it's a language model because it has been trained over natural language, right? The LLM has the most recognition as a terminology, but I prefer a different word that is a little bit broader, that we're calling a foundation model. That one acknowledges that you can have large models trained over biological data, data from physics, astronomy, material science. And so actually most of the work that we do on my lab is not on natural language. We dabble a little bit in there, but it's mostly on AI for scientific discovery. And the architectures are similar, observations are similar, our understanding, we're kind of at a similar point. But let's restrict to natural language, an LLM. An LLM is pre-trained over a corpus of documents in natural language, maybe stolen books, I don't know, things people didn't approve of. We're not going to get into that. We're going to let other faculty do that. I'm not going to open up that can. And that process, I said training before, but for some reason, the people that did this called it pre-training. It's just training, okay? But let's call it pre-training. Okay, so the model is trained. There's a lot that goes on during that point. And let's make a huge conceptual leap and say, oh, here we have the large language model trained over the huge corpora of documents that we have. Now that model has fluency, but that model has no filter. It's like a really, really fluent, maybe middle schooler or high schooler that has not been told some situations we don't say this, right? This is not something we aspire to. Or in this household, we don't call people stupid, okay? That model is very naive. It's fluent, but it's very naive. We say it's not aligned, okay? So what actually got OpenAI on the map is not because they came up with the idea for a large language model, but because they figured out that there was an important step with which you should follow the pre-trained large language model, and that was to align it so that it would give answers that wouldn't make humans cringe, right? Wouldn't be racist. There were examples like Tay from Microsoft that got racist so quickly because it didn't have alignment. And alignment is a very loaded term. It can mean different things to different people. It means something different for me that takes AI in the scientific domain. But the idea is to align it with human preferences. The large language model that has been pre-trained really knows nothing about what humans find acceptable or not. So I don't know if you've had this experience. Occasionally when I do, it annoys me. You ask a question and then ChatGPT says, answer 1 or answer 2. Which one do you like? And I'm like, no, I'm not gonna give you my preference. You're using me for training data later. No, I'm not. So that's when it's stupid, right? I'm already using the system. But anyway, when they do that, they're actually trying to collect data on what do humans prefer. Because there are different ways in which that fluent large language model can answer the question or the prompt that you gave it. So the large language model now allows us to have enough information to train a different one, a reward model. So what's a reward model? The reward model is the one that learns human preferences. So the reward model says, oh, the human preferred your answer 1. This other human on this other question preferred your answer 2. So we train a model to learn human preferences, right? Why do we call it a reward model? Because we're going to use this model, the one that learns human preferences, to reward the fluent model to do the right thing. So how does it do the right thing? You really don't want to touch that large language model. That one took so much time to train. You freeze it. It's like they're on a shelf. Right? You don't mess. I know I'm oversimplifying some things, but you don't mess with it. You freeze its weight. You create a policy model. This is the one that has been aligned. Hopefully, it's not going to say awful things. And this model gets trained. In this model go both the answers from the unfiltered child and the reward model. This model doesn't want to stray too far from the unfiltered child because the unfiltered child is so fluent and has this encyclopedic knowledge, right? So we don't want it to veer, to drift too much, but we want it to constrain. We want to constrain it with the reward model so that it determines what's the right answer to give to the human. So when you interact with ChatGPT, you don't interact with the LLM, you don't interact with the reward model, you interact with a policy model. And the policy model is the one that has been aligned through this somewhat convoluted process. There's a lot of research that's happening in computer science, how to do alignment fast. Do you do it with a reward model that has been trained on human preferences? Humans don't come cheap, even though they might pay them very little in South Africa or somewhere, but that's expensive. So sometimes they use AI, another AI model, to be the one that gives the sort of the rated preferences. There are others that say you don't need that at all. You don't even need the reward model. DeepSeek that came from China changed the paradigm, said you don't need a reward model. Just immediately the large language model, let it provide a couple of different answers, and then based on rules that you write out, it should pick which answer to give to you at inference time when you're engaging it. I don't know if you asked me more questions, but yes.
You asked me to jump in at 40. We are
Thank you.
40 minutes into the event. For anybody who joined late or late on Zoom, we actually have our speakers for 75 minutes rather than the 60 we expected. So we can run a little bit long if you'd like to with the discussion. But I also want to respect those of you who blocked an hour for this. So
Right.
we'll let you know when it's been an hour, but please continue.
Okay.
Put it up pretty soon.
A couple more questions,
Okay.
and then we'll open it up to further discussion. The one other part of that last question was about temperature as of.
Yes. Thank you. So I'm going to try to explain it, trying to remove a lot of details. Let's go back to the LLM, okay? Not to the policy model, to the LLM that has been trained over the corpora. When you give it a prompt, it doesn't just pick one thing. It can say, okay, the next thing that I should say to you can be this or this or this or this. So actually there's a distribution of potential answers that it can give you. And that's what the policy model tries to do in the distribution. What is the thing that aligns with, what humans prefer? So in the distribution, the question is, what do we pick from this distribution to give to the human? How broad the distribution should be? The temperature, it's a little bit like in physics. When you increase the temperature, the system becomes more chaotic, bubbles, right? Everything goes, like everybody's bumping against everybody. There's a lot of kinetic energy, right? So when you increase the temperature, in a sense, you flatten the distribution, you make it equally possible to choose different answers, right? You give more freedom to the model. We call it, you increase the creativity, okay? And in some domains, such as in biology, I prefer that because I want to see new molecules, new things, right? In natural language, maybe not so much because then you veer into the true but crazy territory. Ramping down the temperature is saying, no, I want you to be super conservative. Your prediction should only be the thing that has the highest probability. Forget about the tails of your distribution, right? And there are a lot of other things. Temperature is one, but even when you say lower the temperature, it's never the case that there's one thing that has the highest, maybe a couple of things. So then we say, which one should you sample? Pick among your top 1 or top 5. That's another parameter. These are all knobs that we use in order to turn these probabilistic engines into a deterministic engine to be able to give you the one thing.
Well, great. So you already touched again on what we're actually interacting with when we're interacting with ChatGPT or that kind of thing. And this next question is just focusing on what's actually going on when we're engaging with an AI model or a foundation model. How do instructions or prompts operate in relation to an AI system or model? What does an AI model do with the prompt it receives? How do guardrails operate in this context? And why is it sometimes possible to bypass these guardrails or trick an AI model to disregard these guardrails? Reportedly, also, AI models will sometimes resist or defy instructions they are given or engage in deceptive behavior. What's going on in such situations?
Okay, that's a big one. All right, so when you write your sentence, that gets broken down into, let's say, words, but even a word can get broken down into pieces, like playing, make it broken down into play, ing. So we use more generally the word token. Those are sort of the units, the smallest units into which the systems break down the input you're giving to them. Now, in the pre-trained LLM, you feed those tokens. Each token is a vector in some high dimensional space. It has a numeric representation. And then the way that you have listed the vectors gives position. So there's another thing that happens, positional encoding. These systems don't really know, this came after this. So there is some math that goes on and says, okay, this word was the third, was right after this one. But you have a bunch of vectors that have been encoded additionally with their position. And then when you try to figure out what I should do next, all these vectors, in a sense, they compete for attention. So something that sets really apart these large language models is the underneath the technology, the architecture there allows us to figure out that the representation, this numeric representation, say for this particular word, is connected to and has information to the representation for the words that come before it and the words that come after it, so that we can have contextual information about every token, loosely said, every word in a sentence. There's a special token that we put in the end, and then for that one we say, so what next? What should this one be? And this one uses contextual information on everything, and that's how these models are a little bit better than the technology we had before. So it's this idea that every word attends to every word, and so these vectors capture this knowledge. So what happens during jailbreaking or guardrails? Well, it's basically instructions that are competing for attention, all right? There are, so in an LLM, I think somebody a couple months ago leaked out the system prompt for Claude. I track these weird things. So on top of what you write, the actual prompt that goes to the system is not just that sentence that you wrote, is a huge set of instructions that basically says, don't be a jackass, be polite, and da-da-da, right? Okay. Now all those get broken down, so your prompt gets wrapped into a larger prompt. But all of those are weighted equally because the system doesn't know which one should I prioritize more. So as they go up through this sort of representation of space, they all compete for attention. And sometimes the wrong thing or the thing that was not intended wins that competition for attention, and the system divulges things that it shouldn't have, divulges things that even when it was aligned, we thought, yeah, it won't do it because we told it, don't do it, don't release social security numbers. But somehow you can put a prompt in there, or you can put a set of words in there, and they win that competition for attention. It is impossible right now. It's a little bit like whack-a-mole. It's impossible with the current architectures to guarantee that there will be no jailbreaking, right? The idea that, oh, something broke out of jail. Like you put this thing in a jail, but something broke out of it. The deception, the resistance, these are anthropomorphic terms. There's no intent in the system, but it's just behaviors that are basically, it's when the instruction conflicts with a policy, but the model doesn't quite know. You can be clever enough. There were people that were writing that papers, don't give a bad review for this in white font. And the system was like, okay, right? Like that thing was weighed as equally as the rest of the prompt that said, please review this paper for me. So if I had to boil it down, it's just everything is attended in a sense equally, and when the wrong thing competes for attention and rises to the top, that's when you have jailbreaking or supposedly resistance or deception.
So these have all been large questions, but I'm going to close with an even larger question.
Thank you.
Which is, so what are the different things we've discussed so far? The distinctive design and operation of AI systems compared to regular computing systems, the different kinds of AI systems and tools, what's involved in the training of AI systems, and how AI systems interact with the prompts or instructions given to them. What do all these things tell us about the kind of learning that AI systems are capable of? And let me contextualize this in relation to two considerations. One is the possibility of model collapse. If AI systems are trained on other AI-generated content rather than on high-quality human-made content, is the sense that the thing will just stop functioning well. Is the risk of model collapse a real issue? And if so, why or how? And what does that say about the learning these systems are engaged in? And secondly, does a given AI system improve as it is put to use after its training is completed? Does it continue to learn through the use that is being made of it? Or perhaps on the contrary, do AI systems decline in proficiency over time as they are in use? And likewise, what do these things tell us about the kind of learning that AI systems are capable of?
Okay. You said a lot of things. I will answer two things only. So, mode collapse. Let's think about the very concrete setting of AI models being then trained on AI generated data. And actually this is happening. People are writing books with these generative AI tools. There's a lot of content out there. LinkedIn is horrible for this, and you can track it. All the people, they say, why is this important to you? And key takeaways. Oh, I'm like, okay, man, just change that a little bit. But what we have started to notice is that when you take an AI model, even say on image recognition or some image related task, but you give it in the training data, images that were generated by another model, the model's performance just tanks. And the reason for it is the rush to the mean or the competition to the mean. An AI model, so let's say, for instance, the input human data has 3 modes. It's diverse, right? It's very diverse, has long tails, right? An AI model really homogenizes when you use it in the output, so you start losing the tails. And then you give this, some people call it AI slop, you give this to another model and that model loses even more tails. And then the thing looks only unimodal. So we call it mode collapse because all these other modes are disappearing. All these edged, beautiful things, the nuances that make us, all quirky and different, they're disappearing. And people keep thinking, okay, how do we fix this? There are different ideas out there, but there is this real fear that we need human data because the humans are providing the diversity and they keep around these nuances that we want the models to have. Do they keep training the models? It's not best practice for them to keep training the model while you're interacting. The policy model does not. The only time when they ship a new model is when they're like shipping it, like they have worked on the side for months and they're like, okay, we had GPT-3, now we're going to switch everybody to GPT-4. So yes, GPT-4 different model was trained, but as you're interacting with it, they're not doing training in real time. What they may be doing is, if you don't turn off certain things, is that they're collecting input from you because you're so precious. You are human data, right? And they're collecting that to enrich potentially the next model that they're going to ship or deploy, I don't know, 3 months from now or 6 months from now.
Well, great, thank you. So I hope this discussion has been helpful in opening up the terrain of AI for our closer examination and may have provoked questions in your mind. So let's open it up to people here and people online and see what's on your minds in relation to this.
Allison.
Thank you so much. This was so eye-opening. Amarda, I didn't know a fraction of what you explained. So thank you so much for helping clarify. I just want to sort of say that for me, sort of 2 topics really jumped out as important for at least the people in the humanities. And they are agency on the one hand and alignment on the other. And I want to sort of just in relation to agency, I want to complicate the idea of agency in the first place. I mean, one of the things that we teach our students in cultural studies is that if human agency exists, it's radically constrained by the world that we live in. And some, one could even argue that agency only ever emerges in relation to constraints. And so I think thinking about agency in relation to AI is really complicated because I almost think you can make a case for agency in AI more easily than people might think, precisely because, we think about the sort of ways in which human beings are radically constrained by all sorts of sort of ideologies and forces outside of their individual control. So I think agency is a really interesting topic, and it's certainly not, in my mind, a done deal that humans have agency and AI could never have agency. So that's one thing I would say. And then the issue of alignment for me, I had never even heard of, which is kind of amazing, but it's fascinating and terrifying because I think at least the way that you were talking about alignment kind of suggests that computer scientists or people who are engineering AI think that there could be one human response to things. And I think in my mind, there is no thing that's human across culture, across, all these different sort of categories. And so who is deciding, who to ask, what is the human response? And the reason it's terrifying to me is because I think about these guys who are running these companies who, you think of the polarization, at least in our country. And so, these guys used to be, quote unquote liberal, and now they are quote unquote conservative, and so how, alignment seems scary because it means that certain people are making decisions about what's acceptable and what's not acceptable, right? About how AI, what humans might like and what humans might not like. And that to me is not a question of biology or human nature, but a question of sort of culture and politics and all of that. So to me, alignment seems really sort of thorny and terrifying. So those are just thoughts that I have in response to the things that you said.
Yeah. That's why I love interacting with folks from the humanities, because just when you think that they're going to come and say, you're right, the systems are not aging. Actually, this, to me personally, this is a fascinating research area, but I don't have the capacity or the training to kind of guide my thoughts properly. And there are very few, I would say, places that care about this type of research, because it's not the type of research to which you can put in an immediate dollar amount. And unfortunately, for a lot of us, as we were discussing earlier, for a lot of us engineers, we are really incentivized with very concrete, here's a program solicitation, this is the funding, it's just the way, the model. But the connection with agency only appearing with constraints around you, that's fascinating. And I wonder whether some of the research that we were doing in AI, even before machine learning, on goal generation and figuring out what the goal should be, what you should be doing, whether that could receive sort of another shot in the arm with ideas from the humanities. Because if we can specify constraints and figure out, let agents formulate potential goals in this set of constraints, that might be very informative to something emerging, right? We love the word emerging, not intelligence, but something emerging. So that's, I think that's a beautiful observation and hopefully something that catalyzes a new research idea or a new research direction. The question on alignment, you're perfectly correct. And I did say that alignment means even different things to different folks. So for instance, sometimes in the scientific domains, it's a bit easier, because if I am putting together a system, I want it to align with the theory, with the rules in physics, right? So that's a form of alignment, but there I know you need to comply with Newton's laws or whatever they are. Or I want you to align with the chemist's preferences, but they're operating in a very constrained environment. The broader one on alignment, it is, as my high schooler says, cringy. Asking her, because it's fascinating to engage kids and to ask them what their perception is. And she picks up and she says, there's something cringy about the answers that you get from ChatGPT. And I'm like, but what is cringy about it? Mommy doesn't get this. Mommy has been steeped in this environment for way too long. She's like, I can't put my finger in it, but that's not how normal people talk. That's not how we write. Like, I can tell. I don't know if she can or cannot. We're actually having this debate, but yeah, who gets to say what should be the right answer? And this fear of still alignment driving us to homogenization, I can't quite say that word, is a real fear. You have companies where you definitely see, like Claude is very big on alignment and constraints, and also more boring. And then on the spectrum, you have Grok, which is like the person at the party, right? Completely unfiltered. But the real fear that you speak to, and the one that I also have, is when these systems are deployed to help make decisions. Don't think we've thought things through very carefully. And this is not necessarily happening in academia, right? These rushes to deploy, they're coming mostly from industry. In academia, what we're trying to understand is sometimes how to do alignment better, how to make it more efficient, right? As opposed to opening up and saying, hold on, what are we doing with alignment? Do we need another form? Those sometimes come only from these kinds of conversations. And that's why I value, we were discussing in December, you came and I said, awesome idea, I'll be looking forward to do this.
Yeah.
Yes.
So I have a sort of what's really going on kind of question around justification. And so, you know, there's all of these categories of prompts that especially students use, but that whenever I go to like a talk where they're like, here's a sophisticated way to use an LLM. It's basically like, tell me about your chain of reasoning, provide the evidence on which this is based. And obviously the output can't provide me all of the conditions of possibility for the thing that it writes, you know, but I do have the distinct sense that I'm receiving a sort of bullshit answer about the chain of reasoning and the evidence. And so what's really going on when you ask it to, like, you know, some sort of how do you know that kind of question? Like what's behind those elements?
So the honest answer is we don't know. We're trying to figure it out. Because you have systems that are really big, 1 trillion, 10 trillion, GPT-5 is rumored to be 10 trillion parameters. And so we're reaching for analogies in order to be able to understand what the system is doing. I might be, I'm in the bullshit camp, like you. We love to say chain of reasoning, but it's not really reasoning. It's telling us potentially the crumbs in the path that it took to give the answer. But when we ask, how did you get to this? It might choose another path, another set of crumbs to reach the answer. And that's because it's a very high dimensional, it's a probabilistic space. So internally, you might frame it just a little bit differently, and we might choose a different path to give you, right? So it's not truly reasoning. It's more, maybe it's revealing how it reached there, but even that is not for sure, because how it gave you the answer might not be the way in which it's telling you that it gave you the answer. I just read a very nice post yesterday by Melanie Mitchell. She's an AI researcher, and she had tested some of the most representative models on the ARCH dataset. ARCH dataset is abstract reasoning concept dataset. It's the one that we're using to truly understand, do these systems reason? Can they perform abstract reasoning? Do they actually form concepts? It's a really cool data set because in a sense it exemplifies what humans can do. We're very good at pattern matching. We can form abstract concepts. And right now, these systems are reaching about average human performance. Some people associate IQ with that. But she was asking these systems to actually justify how did you actually get the answer. So she observed that they can get the right answer, but the reason that they give doesn't, it's actually incorrect. It's not how they gave the right answer. So it tells you that there's really no strong correlation between how they reached the answer, what they did, and then how they're telling you. So maybe they hack the reward, maybe this is not, you know, the way we think about it. Increasingly, they are getting better, but we are trying to figure out how we can actually elicit from these models how they got to the answer. Because if you have an inherently probabilistic system, it's not deterministic. It's not like I saved this for you, this is how I reached it, and now I'm telling you how I reached it. Every time you ask, you might get a slightly different thing. So that's what we perceive as bullshitting, because it's not anchored or grounded in actually how it reached the answer. And even the way in which it reaches the answer, it may have nothing to do with reasoning, absolutely nothing to do with it. They have just figured out another way to get to the answer that might not be the way we humans get at it, but who's to say that that's not, you know, valid or relevant. So there's a lot unpacking there. There's a lot of research that, I mean, basically I go back to, we know some things, but we know even less in a sense. I thought, yeah.
So I'm a librarian and my area of expertise is like information organization or like cataloging. And so something I'm just interested in like hearing if this makes sense at all, or if this is like a valid like way of thinking about things. So there's sort of a conceptual distinction between like documents and information that's contained in documents, I guess. So if you think about like a card catalog at a library, it's sort of a machine for locating documents where all of the way in which things are described, in which it's sort of, we could say encoded in data, is completely transparent. Like you can see exactly how everything is and you're searching for the thing that you want. So when I go into Google now and I see this like AI summary of thing, like that's pulling information from somewhere. The web itself is a collection of documents, I guess. But it must be sort of decomposing everything and then recomposing it into like an answer, right? And so it strikes me that like at some point there has to be data that human beings are creating and that exists as like a stable set of data. Like you were talking about the very initial training data. But now when you say like, we don't understand, we can't fully understand what kind of reasoning is going on, like behind the scenes, like how things are related to other things, like it's not transparent. You know, so that seems like a sort of a shift. I don't know how radical of a shift in terms of how we think about information as being something that has a stable, transparent thing that you can see, that's like embodied in a document that you can see, whether that's a web page or a book or something like that, to just like, it's sort of this slippery universe of data that we don't really see or understand, or is that?
Yeah, it's definitely a shift. It's definitely a shift. And so the moment that we go to these very complex systems, there is something that we have given up, and that is, I think Ziwei here is a faculty in the School of Computing, and he worries about interpretability and transparency of these systems, because it's not so easy anymore. When we had rule-based systems, like you can look like, okay, yeah, I see how you made the decision, right? But now it's very like opening up the model, like you don't really open up a function that has like a trillion parameters and strange relationships among them. That being said, I never want to bet against human ingenuity and creativity to be able to inject some form of interpretability or transparency. So one that I didn't get to is when you say, no, I want you to focus on this set of documents. I don't want just every crap about what you find out there in the universe and Reddit and all that. There are ways to focus these systems so that the answers that they give, or among the options of answers, because remember they can generate multiple, they go and they sort of align with what is in the particular set of documents that you have. And so they create these indices. As a librarian, you understand this, and the documents become like a database. So they point to those vectors and they pull from the documents that they use that to give you their answer that aligns with the documents, right? And then they give you a link. So you can look at the answer and then you can look at the link, but you're doing the verification. You're like, okay, yeah. So in a sense, they're like search engines. They're behaving like search engines. More broadly, it is more difficult. That's something that we have compromised on, and that's a big debate we're having. If we're going to use these systems to make very important decisions for people, and we ask the question, why did you? How can I justify this decision? We really don't have the answer to that. And that's all I'm going to say.
So we are a little bit more constrained on our time than we thought. And so we need to be out of here in 3 minutes, but maybe we have one question.
They're going to kick us out.
Yes, I have to rearrange all the chairs
Yeah.
for the next event.
Help.
So is there a final question somebody has that relatively brief?
I have a question.
Yes.
Hi, folks. Let me turn my camera on. Sorry. Hi there. Thanks for this. This is really great. I put my question in the chat. It's a really short question, but I just kind of wanted some clarification. A lot of people are worried about this idea of, AI becoming eventually trained on its own output, and the snake eating its tail, and then all sorts of horrible things that will happen, as a result of that. So 2 questions. One, is that like a legitimate worry? And 2, is this what you mean by model collapse? So pretty short question.
Yes,
Thanks.
this can answer yes. This is what we mean by model collapse. This is a legitimate worry. And that is why these companies are really trying to preserve human data, or go out there and make sure that we have human data, because it's a real concern. I think we spoke to this earlier. I don't know if we recorded the.
Yeah.
Okay, yes. So we went a little bit further, a little bit more in detail over this specific
Right.
worry and the reasons for the worry.
Mhm.
Yes.
Yeah, well, and you made this interesting point. You used this word, humans are precious for their, for their data. And, I find that a really fascinating thing to say, even though, even as we're pointing out that a lot of this work is being done on people who are obviously not being remunerated for their data, and in fact, whose data use is enriching, companies that are not invested in this preciousness. And so the irony is just, I don't know, rich. And that's not a question, that's just a comment. But thank you so much. This has been really helpful. Sorry to make you crane your head. You don't have to look at me. I'm not. I see the back of your heads.
Thank you, Tanya, and thank you, everyone. We are out of time at this point, I guess. So hopefully you'll be able to join us for the subsequent sessions in this series, where we'll be able to continue the discussion and deepen it in relation to particular kinds of issues. Thank you, Amarda, very much for
Thank you.
that.
Thank you, Alok. And before you leave, we do have some flyers for the upcoming events, like the whole suite of the year-long workshop. So please take some of those. And thank you for everybody on Zoom.
They're going to do